let's talk a bit about stationary points. So those are the rules itself and how we actually derive and do all of that stuff. So let's talk about how we actually can use our differentiation. So when we derive something, what we're trying to find is the gradient of the function, right? So when we find the derivative, a synonymous for that is we're trying to find the gradient. So that kind of enables us to find stationary points, and the word stationary points kind of gives away what type of points there are. They're literally when they have zero gradient, so it's not moving, so that's when there's a zero gradient. So what we're going to do therefore is try and find when f dash of x or dy dx equals to 0, and we can solve for the x coordinate using that. There's 3 points at which we can kind of get a stationary point, and these are turning points, so local mins and local maxes, and stationary points of inflection. So those are the 3 points that we can actually get a stationary point as. No other point on the graph will really be a stationary point. So once we solve for stationary points, so once we solve f dash of x equaling to 0 or dy dx equaling to 0, we can then determine their nature. So there's kind of 2 ways to do this. We can either sketch the graph, which can be easy for some and can be more difficult for others, right? Because like for a cubic or something, we kind of know the general shape of it, so it's okay to graph. But for something which is a bit more funky, it's probably a bit gross to do. And in fact, you are probably finding the turning points and stuff to actually help you know what the shape of the graph looks like. So you can use something called like a gradient table if that doesn't work. Which is finding the gradient immediately before and after. We'll do both methods kind of here to talk about how it works and how we can use it together. So it wants us to find the stationary points of 2x cubed minus 3x squared minus 36x. And so the first thing is we want to find what f dash x is. So even if you don't really know what's really going on, but you get the vibe that you'll have to do something with differentiation, just derive. You'll get at least 1 mark, because you've at least done the first step. So if we try and find what f dash of x here is, or more appropriately dy dx here, because everything's in terms of just y, it will just be 6x squared, so we took down the power, reduced the power by 1, minus 6x, so take down the power, reduced the power by 1, and then minus 36. Now, we're now going to try and find the stationary point, so that means that dy dx equals to 0. So we'll have 0 equals to 6x squared minus 6x minus 36. So what we're going to do is now we can just divide everything by 6, so we don't need as big numbers. So it'll just be x squared minus x minus 6. Cool. Now we can kind of factorize them into 2 brackets. So that's going to be x minus 3, x plus 2, right? So therefore we'll have x equals to 3 or x equals to negative 2. Alright, so now we need to determine the nature of these things. So we can kind of just have a go at determining the nature. So there's, like I said, there's 2 ways. There's really actually 3 ways. There's also something called the double derivative as well, which I guess the use of it's not encouraged in methods, and I wouldn't really use it in your SACs, but it should be fine to use it in your VCA exams. So just keep that in mind as a method as well. And it's essentially when you just find the second derivative and then you sub it in. We can just have a brief chat about that as well. But essentially what we can do here is we'll just kind of set it up. So we can just graph it actually instead. So we'll know that this graph approximately, I'll probably need to find the turning points and everything then. Okay, that's right. Let's try and find the points, like all of the turning points and stuff. So not the turning points, the x-intercepts. So if we subbed in 2 there, we would have gotten 16 minus 12. So that's negative 28. So that's not quite right. Oh, no, that's too big. Okay. What about 1? So that's 2 minus, no, that's definitely too big. What about negative 2? So that's going to give us negative 8 minus, no, that's too small. So then 3. So what I'm just doing is just the factor theorem for the polynomials. 3, so that's going to be 27. Negative 54. Negative 54 minus 27. Oh, no. Negative 54 minus 27. So negative 61, negative 81, and then that times by 3 would be 18, 108. Okay. If we had, if we were allowed to graph this on our calculator, just so we can make sure to get through all of the content, 2x cubed minus 3x squared minus 36x. Okay, so I guess one of the points would just be 0, right? It's a good point to take out. So it's points pass through 0, and then we have 2x squared minus 3x minus 36. And then we can do like quadratic formula on that. But we kind of know that the general shape is going to look like this, right? Because it's a positive cubic, so it's going to look something like this. And therefore we can tell that this is going to be the max and this is going to be the min immediately. So we're pretty happy. Like that's one of the ways you can do it. Another way you can do it is via the gradient table. So what you do is you just put in the points, and so I'll have negative 2 here and I'll have 3 here. And I like to sandwich this, so I have to find one less point. Just makes life easier. So this is x, this is f of x, and this is what the lines look like. So at negative 2, we should get 0, right? Because if we get negative 2, that's going to just equal to 24, you know, and it should give us like the number that we need, right? Because we should get, so negative 24 plus 12 and then minus 36, so we'll get 0 here, 0 here. We can do 0 in the middle here, and then do negative 3, and then I would just do 4 here. Just two like simple numbers is better. So if we sub in 0 here, we'll get negative 36, which is smaller than 0, so it's going to go down. So we'll have 0, so these are flat lines. And then we'll have negative 3, so negative 3, so that's going to be 9 times 6, so that's 54, plus 18, so that's going to be 54, 64, and then 72, so 72, then minus 36, that's going to be positive 36, now that's going to be up. And then we're going to sub it in 4, so 4 squared is going to be 16, 16 times 3 is 48, so that's 96, so 96 then minus 24 is going to be 72. Once again, it's going to be 36 here, so it's going to go up as well, and we can kind of see down, down, down. So once again we get the local max and then local min as well. Cool. And then in terms of the second derivative, so f dash dash of x is going to just be equivalent to 12x minus 6. So if we sub in those 2 points, so negative 2, f dash dash of negative 2, that's going to give us negative 24, negative 30. So if that's smaller than 0, it's a local max. If it's bigger than 0, it's a local min. And if it's equivalent to 0, we don't really know, but it's a point of inflection of some sort.